So for today's lecture, we are now in section 2.5, roots and radicals. So we will introduce now um, exponents having fractional powers, okay? And then we will convert it to roots or radicals. And conversely, from roots to radicals, we will convert them to exponents with fractional powers. Okay, so first we define the principal and truth of a real number a for n greater than or equal to 2 and n is an integer, which is symbolized as this guy here. Okay, and this is defined as follows. So this symbol, and this is read as the nth root of a. So this is equal to b. This means that a is equal to b to the n. Okay, so the nth root of a, this is equal to b, and this means that your a must be equal to b to the n. Here, a and b are both greater than or equal to 0 if the value of n is even, and a and b can be any real number if the value of n is odd. Okay, so the left hand side we see here the roots or the nth root, and later we will know the actual name of this, but I'll introduce it. It's called radicals, and then this is equivalent to a certain power. Okay, so nth root of a, that's equal to b. It means that the value of a must be equal to b to the n. Okay, so when this guy here it's defined, okay, the number or the value of nth root of a, this is the number that when raised to power n, okay, it gives a. So nth root of a, it is a number. Say that's the number b. Okay, so it is the number such that when you raise that number b to power n, which is this guy, it gives you a. Okay, so we have it like this, and root of a equals b if and only if you have a equals b to the n. Okay, and like what is written here in the definition, we have the following condition. So a and b, they are both greater than or equal to 0 if n is even, and a and b can be any real numbers if n is odd. Okay, here are some remarks and possibly properties of nth roots. So if a is negative and n is even, okay, if a is negative and n is even, then this guy here, this symbol here, this is not defined. Okay, so we do not take the nth root of a if n is even and a is negative. Okay, now when it is defined, okay, when it is defined, the principal nth root of a of a number is unique. So there will only be one principal nth root. Okay, and it will be almost all the time the positive side. Okay, it will be almost all the time the positive side, especially for n is even. Okay, and of course when n is odd, when a is negative, okay, when n is odd, when a is negative, then the principal nth root will also be negative. Okay, but it is unique. There will be no other principal nth root. Okay, the symbol, this guy here, for the nth root of a, it's called a radical. Okay, it's called a radical. The integer n, this n here, it's called the index. And a is called the radicand. Okay, so the whole thing, it's called a radical. The n that we see here, it's called index. And the a that we see here, it's called the radicand. Okay, now if the index of the radical is 2, we simply write this symbol here. So we will remove the 2 there. Okay, and it's called the square root of a. Okay, so we'll just remove this 2 here. We'll just write it as this guy here, and it's called the square root of a. And if the index is 3, we call it the cube root of a. Okay, so this symbol here, it's called the cube root of a. And for any other else, let's just call them um, as usual, fourth, fifth, sixth, etc. As in this guy, the nth. Okay. Some examples here. Suppose we have this fourth root of 16. Okay. Now, the 16 here, you can write it as 2 to the power 4. Okay. So 2 to the power 4. So the fourth root of 16, it's the same as the fourth root of 4, and um, that's equal to 2. Okay. And if you use the definition, okay, so this means that uh, you have 16, that's equal to 2 to the 4. So fourth root of 16 equals 2. It means 16 is equal to 2 to the 4. Okay, so 2 here, it's the principal square root um, of fourth root of 16. Okay, question. Now, you may think of the following. So you know that if you have negative 2 and you raise it to power 4, this is also equal to 16. Correct? You have negative 2 times negative 2 times negative 2 times negative 2. Okay? That's equal to positive 16. And you might say that, oh, because of that, I will have fourth root of 16. This is also equal to negative 2. Okay? Fourth root of 16, that's also equal to negative 2. Okay? Now, if you go back to the definition in here, okay? If you go back to the definition in here, when n is even, both a and b must be positive or equal to 0. So where a and b, they are both greater than or equal to 0 when n is even, which means that in here, okay, in here, this guy here will not follow the definition that we are going to use. Okay, are we good? In fact, this is not the principal square root or the principal fourth root. The principal fourth root would be equal to 2 and not equal to negative 2. Okay? Questions?
Is it possible to get like a negative number with the root?
Of course, when you have cube root. Okay, for example, later we will see an example where you get cube roots or the fifth root of negative numbers, you get negative. But if you
Okay.
have even index, okay, the root must be positive. Square root, fourth root, sixth root, etc.
Thank you.
Okay. So for the next example in here, we have the cube root of 1 over 27. Now, 1 over 27, you can write it as 1/3 to the power 3. So if you take the cube root of this is equal to 1/3. Okay. Next problem here. This guy, you have the fifth root of negative 243. This negative 243, you can write it as negative 5 raised to power 5. So if you get the fifth root of this is equal to negative 3. And as you can see, you get now a negative number. Because, of course, your radicand here, it's negative, and your index, it's an odd number. Okay? So like I mentioned earlier, an odd number, okay, for the index, if you get the nth root of a negative number, it will give you a negative number also. Okay? If you get the um, nth root of a positive number, you will also get a positive number. Okay? That's for the odd powers or for the odd index. And of course, for even index, we only have positive numbers there. Okay? So this is the principal fifth root of negative 100, negative 243. Okay? And what if we have written it this way? So just like my example from before. You can write, for example, this negative 6 raised to the power 4. Okay? So you have 36 times 36, correct? And if you have that, okay, you will get 1,296. So this guy here, this is fourth root of 1,296. So even though you see negative here, but this whole guy here, the negative 6, it's being raised to 4. So when you raise negative 6 to power 4, you will get a positive to 1,296. Okay? So it's still a positive number. Okay? Now, since we have written it this way, and we said that if we have a positive radicand with even index, okay, the number or the root must be also a positive number. That's why we have here positive 6 as the fourth root of negative 6 to the power 4. Okay? So what really happened here is that if you are going to write, just like in this illustration here, just like in this illustration here, okay, if you are going to write 16, okay, if you are going to write 16 as negative 2 quantity to the power 4, you will still get positive 2. Okay? You will still get positive 2 and not negative 2. Okay? And the actual definition there is with this guy here. You see these two bars in here. If you are not familiar, this is called the absolute value. Okay? This is called the absolute value thing. So absolute value. Okay? And we define it as follows. So you have the absolute value of x. This is x if x is greater than or equal to 0, and it will be negative x if x is less than 0. Okay? So try to remember this definition. We will be using it um, sometime. Okay? We'll be using it sometimes. So if you want to get this guy here, you see absolute value of x, that's equal to negative x. It's if x is less than 0. For example, this guy here, you have the absolute value of negative 6. And we said that it's actually equal to positive 6. So intuitively, if you have an absolute value for some number or of a number, you will just get the positive side of that. Okay, you will just remove the negative sign. Okay, but in definition, it's this guy. Since you have here negative 6 and x is less than 0, this is equal to negative of negative 6. And well, negative of negative 6, that's equal to positive 6. Okay? If you have, say, absolute value of 3, since 3 is positive, we just use this guy. Okay? So this is just equal to x, which is just your 3. Understood? The absolute value. Okay? So in general, if n is greater than or equal to 2, and n is an integer, and a is a real number, we have the following. So the nth root of a to the n, that's equal to a if n is greater than or equal to 3, which is, and also an odd number. On the other hand, if you have nth root of a to the n, that's equal to absolute value of a if n is even, n greater than or equal to 2, and n is even. Okay? So intuitively, it's like you are canceling the root and the power. Okay? You are just canceling the root and the power. So you have fourth root here, to the 4, you get 2. You have cube root here, you have 1/3 to the power 3, you'll just get 1/3. Okay? In here, you have fifth root and you have negative 3 to the power 5. The 5 cancels, so you have negative 3. Okay? But more importantly, if you have negative 6 to the power 4, okay, and you raise, if you get the fourth root of that, it's not, you're just canceling it. It's not the same as the cancellation. You have to take now the absolute value. Okay? Question? Okay, so some properties here. If you have a product AB and you get the nth root of that, that's equal to the nth root of A, nth root of B. Provided, take note of this, provided this is defined here and also this guy here, it's defined. Okay? So in a sense, if n is even, then both A and B here must be greater than or equal to 0. If n is odd, then A and B can be anything. They can be both positive, they can be both negative, or they can have different signs. So assuming that the right-hand side, the terms and the right-hand side are all um, defined. And of course, just like product here, we have quotient. So nth root of A over B, that's equal to nth root of A divided by nth root of B. And again, provided the radicals here are defined. And if we have the following, so you have A to the M, then you get the nth root of that. This guy here, it's the same as the nth root of A, then you raise it to power M. So in the left-hand side, you have A, you raise it to power M first before getting the nth root. On the right-hand side here, you have the A, you have to get the nth root first before raising it to power M. Okay? They should give you the same answer. Okay? Some examples here. We have square root of 18. Okay, we have square root of 18. 18, you can write it as 9 times 2. Okay, your 18 can be written as 9 times 2. And there are other ways to write 18. You can write it as 6 times 3. Okay, so maybe you can write this as 6 times 3. 6 times 3. But we will be using this 9 times 2 instead. Okay? So in here, we have 9 times 2. You get the square root of that. We apply properties here, okay? Particularly this the number 1 here. You can write now this guy here as square root of 9 times square root of 2. But remember, 9, that's 3 squared, okay? 9, that's equal to 3 squared. And from the remark before, you have here, you don't see an index, it's automatically 2. Okay, you don't see that index, it's automatically 2. So you have 2 here and then 2 here, they just cancel each other, quote unquote. Okay, so this will give you 3 square root of 2. Okay, so this is uh, the value of square root of 18. You can write it as 3 square root of 2. And just like I said earlier, you can write this as square root of 6 times 3, correct? And you may want to separate them. You have square root of 6 times square root of 3. But 6 here, you can still write it as square root of 3 times 2. 3 times 2, that's 6. And then you have your square root of 3. And you separate everything. Okay, you separate these two guys here totally. You will have square root of 3, square root of 2, and then square root of 3. But then again, you have square root of 3 here. You are multiplying it to square root of 2 and square root of 3. So this can be written as square root of 3 quantity squared, times square root of 2. So if you look at this, okay, if you look at this, you have square root of 3, but you square it, okay? Same principle. It's like the square root will cancel the square here, or the square will cancel the square root, and you will still get 3 square root of 2. Okay? Questions? Next, you have cube root of 5 over 24. So cube root of 5 over 24. 5, it's just 5 times 1. 1 times 5. It's a prime number. On the other hand, 24, you can write it in several ways. You can write it as 2 times 12. You can also write it as 3 times 8. Or you can write it as 4 times 6. Okay? But we are looking at the cube root of this number. What we're going to do is to write 24 as um, a, a product where we can use the cube root to simplify, quote unquote, this number. Okay? So in here, we are going to use number 2 first. We separate the two guys. We have cube root of 5 divided by cube root of 24. And then from here, we now write 24 as 8 times 3. Okay? So that this expression is cube root of 5 over cube root of 8 times 3. And the reason why we are using 8 times 3 is because this 8 here is actually a perfect cube. Okay? So from here, we separate. So cube root of 5 over cube root of 8, cube root of 3. And then now we write 8 as 2 cube. So you have cube root of 8. That's equal to cube root of 2 to the power 3. Okay? 2 to the power 3. So cube root 2 to the power 3, the 3 cancels each other here in a sense. You have cube root and then power 3, quote unquote, they are canceling each other's job. And therefore, we'll just have 2 in here. So that this guy here, we have cube root of 5 over 2 cube root of 3. That's cube root of 5 over 24. Okay? Next item here, we have cube root of negative 81 x to the 5th power. Okay? So in here, take note, this x to the 5th power, so x to the 5, you can write it as x cubed times x squared. So we are writing this x to the 5 in this form because um, we will get some x cubed and there is a cube root in here. We are taking the cube root of this guy. So it will be nice if there will be something that we can cancel. Okay? Particularly the cube root and the x cube. Okay? They are complements of each other. So uh, they will cancel what one does to the other. Okay? So they will cancel, one will cancel what the other does. I think that should be the better statement. Okay? So in here, we are taking the cube of x. This guy here, we want the cube root of that. So the cube root cancels what the cube does or did. And in here, you have negative 81. Okay? We will write this as negative 27 times, uh, let's write it as negative 3 squared. And you see negative 3 squared, that's 9. That's positive 9. 9 times negative 27, that's equal to um, 81. Huh? Wait. So negative 81 in here. This is, we have this. Sorry about that. So we have this guy here. So negative 27 times 3. Uh, yeah. But negative 27, that's equal to negative 3 cube. And then we have multiplied that to 3 to get negative 81. Okay? So what we're going to do is to join x cube and negative 3 cube because they both have power 3. Okay? And we are taking the cube root. Okay? And then the rest, we'll just combine them. I mean, we multiply them. We group them together. You have the x cube and the 3 here. Oh, the x squared and the 3 in here. Okay? So that this cube root of negative 81 x to the 5th power can be written as negative 27 x cubed times 3x squared. And then we take the cube root of that. And just like I said, negative 27, it's negative 3 cube. And then we have negative 3 cube times x cube. It can be written as negative 3x quantity cube. Okay? And then using this property number 1 here, we separate the two guys. This negative 27x cubed times 3x squared. And so this cube root of negative 81x to the 5th power, it can be written as cube root of negative 3x cubed times cube root of 3x squared. And for this guy, okay, the cube here, is being cancelled by the cube root here. So that we will have negative 3x times cube root of 3x squared. Okay? And take note that since this is cube root, okay, your x here can be anything. It can be positive, it can be negative. Okay? Take note that x here is a variable. It can be any number. But we are getting the cube root of that, okay? Then your x can be anything, positive or negative. And this guy here is still well defined. Okay? Next, we have the fourth root of 16x to the 6. Okay? And then our 16, you can write it as 2 to the fourth power. While your x to the 6, you can write it as x to the 4 times x squared. So 16, this is equal to 2 to the fourth power. And then x to the 6, this is equal to x to the 4 times x squared. So if we do that, we can group together those with the fourth power. And then separate the one that does not have the fourth power. So this guy here, we can write it as fourth root of 16x to the 4 times x squared. And we can do property number 1 again. And furthermore, we write 16 as 2 to the fourth power. So we have this, okay? We separate. We have x raised to fourth power, 16, x to the 4 times, sorry, we have the fourth root of 16x to the 4 times fourth root of x squared. And if we do now the fourth root of this guy, well, we write first 16 as 2 to the fourth power and combine 2 to the fourth power with x to the 4 so that we will have 2x to the fourth power. Then we get the fourth root of 2x to the fourth power. We will obtain this guy here. Absolute value of 2x, and then fourth root of x squared. Okay? Questions? Now, take note, we have the absolute value of x in here. Look at the original expression in here. You have the variable x and you raise it to power 6. So, if you have any number and raise it to power 6, it will always give you positive number. Which means that 16x to the 6, this is always positive. And therefore, fourth root of that positive number, it's well defined. Okay? So, x to the 6, it's always positive, whatever your number is. Which means your x can be negative. The x alone, it can be positive, it can be negative. If it is negative, you raise it to power 6, it becomes positive again. Okay? So that is why when we have our last expression, we need the absolute value. Okay? Because your x can be negative, but you are taking the fourth root. If x were negative, you have this absolute value, it will become positive. The 2x becomes positive. If you don't put the absolute value, then there's a possibility that this will become negative, especially when your x was taken to be negative. So without the absolute value, 2x can be negative, and that is not the principal square root. Okay? And furthermore, this guy here, this is not yet simplified. In a sense, we can still work on this and get a simplified version of fourth root of x squared. Okay? But we'll have that later. Okay? So in here, this guy here, 3 square root of 2, we say that this is the simplified version of square root of 18. This guy here, cube root of 5 over 2 cube root of 3, this guy here, it's almost simplified. Okay? It's almost simplified. Why almost? It's because we don't want to see radicals on the denominator. In here, you have a denominator, and the denominator is 2 cube root of 3. We don't want to see any radical on the denominator. So later, we will learn what we call rationalizing the denominator. Okay? So intuitively, rationalizing the denominator, we are trying to remove the radicals in the denominator. Okay? This guy here, this is simplified. Okay, this guy here, this is simplified. This guy here, this is not simplified. Fourth root of x squared. Okay, so for this type, when do we know if it is simplified? If the expression is simplified? If you have a power inside the radical, okay, if you have a power inside the radical, the power, okay, the exponent and the index must not have a common factor. Then we say that the radical is simplified. So this guy here, this is not simplified because x has power 2, the index is 4, and 2 and 4 have a common factor. Common factor is 2. So you can still simplify this. Okay? Questions so far? Now, later in today's lecture, we will have an easier way to simplify such type. Okay? We will have a simple way or a simpler way to simplify this type of radicals. Okay? Now, in general, the nth root of a plus b, that's not equal to nth root of a plus nth root of b. So remember, when we discuss powers, a plus b to the n, this is not a to the n plus b to the n. So the same thing for the radical. Okay? Nth root of the sum, a plus b, that's not the same as nth root of a plus nth root of b. And just for example, you have here square root of 2 plus 2. Okay? 2 plus 2, that's 4. If you get the square root of 4, you'll get positive 2. Okay? On the other hand, square root of 2 plus square root of 2, that's approximately equal to 2.828. Square root of 2, that's approximately equal to 1.414. So if you add it with itself, you'll get approximately 2.828. And look, they are not the same. Okay? They are not the same. So do not just um, distribute the radical over the sum. Okay? You can distribute the radical over products or quotients. It's like we distribute this square root thing here or the nth root thing here over the product AB. Similarly over the quotients. But for sum, we don't do that. Okay? We don't do that. However, we can add radicals. We can add radicals just like adding monomials or polynomials. Okay? We can combine radicals if they have the same index. The same index n. Okay? And the same radicand. So for example, here you have 2 and 2. So you can combine this. We call them like radicals. Okay? Similar to like terms, the same base, the same exponent, you can combine them. So for radicals, you must have the same index and the same radicand, which means that this guy here, this is actually 2 square root of 2. Okay? Questions?
So the 2 to the square root of 2 that you wrote at the bottom, that's how the 2 square root plus 2 square root should be written correctly?
Square root of 2 plus the square root of 2, that's 2 square root of 2, not 2 squared plus 2 squared. It's square root of 2.
Okay, so when you write 2 square root of 2, that it's written as or it's the same thing as 2 to the square root of 2 to the square root.
Yes.
Okay.
Except that so it's not 2 to the square root. It's not 2
Or
to the square root. To the square root. No, it is read as square root of 2. So it's like when
okay.
you say to the, it's like you are giving it as an exponent. It's like to the power. Okay? But in here we read this as is square root of 2. So square
All right.
root of 2. But yeah, I understand what you meant. Yes. So you have 2 square root of 2. That's the same as square root of 2 plus square root of 2.
All right. Thank you.
All right. You're welcome. Other questions? So let's look at these examples. So we have square root of 8 minus 3 square root of 32. Okay? So here, square root of 8, your 8 can be written as 4 times 2. 32, it can be written as 16 times 2. Okay? So if we distribute this, we will have square root of 4, square root of 2 minus 3, square root of 16, square root of 2. And 4, that's square root of 2 squared. So you have here square root of 2 squared times square root of 2 minus 3 times your 16. That's 4 squared. So you have square root of 4 squared. And then square root of 2. And then in here, square root of 2 squared, that's equal to 2. Square root of 2 minus, you have 3. Square root of 4 squared, that's just 4. Then you have square root of 2 in here. Okay? So, from there, we will have this. 2 square root of 2 minus 3 times 4 square root of 2. And of course, 3 times 4, that's just 12. So we have 2 square root of 2 minus 12 square root of 2. You have the radical here, square root of 2. You also have the radical here, square root of 2. Okay? So same index, both are 2. Same radicand, also both are 2. So you can combine this. And if you combine this is just negative 10 square root of 2. Okay? It's like you are treating square root of 2 as some variable x. Okay? In fact, if you treat it as x, your x has an actual value. That's square root of 2. Okay? So you can combine radicals if they are like in a sense, the same index and the same radicand. In here, we have fourth root of 32x minus fourth root of 2x to the power 5. So 32x, that's 16 times 2x. Okay? And then 2x to the 5, you can write it as x to the 4, 2x. And of course, just like before, your 16, it's 4, or it's 2 to the power 4. So you have fourth root of 2 to the power 4 times 2x minus, of course, you'll just write that, you'll just copy fourth root x to the power 4 times 2x. And then you can separate them. You have fourth root of 2 to the power 4 times fourth root of 2x minus fourth root of x to the power 4 times fourth root of 2x. And then fourth root of 2 to the 4, you'll just get 2 in here. Correct? So you'll just get 2 there. So times fourth root of 2x minus fourth root of x to the 4. This is now simply x. And then we have fourth root of 2x. Now, you might ask, why didn't we not did we not put the absolute value here? Okay? Look at this expression. You have 32x. So that's just x, and your index here, it's 4. So automatically, this guy here will be defined if your x is positive or 0. Your x is greater than or equal to 0. Which means we don't have to put the absolute value because your x will be greater than or equal to 0. Okay? So this guy here, it's equal to 2 fourth root of 2x minus x fourth root of 2x. So this is your radical, fourth root of 2x. The index is 4. The radicand is 2x. And that's the same as the other guy in here. Which means you can combine these two guys in a sense that you can rewrite this as 2 minus x quantity fourth root of 2x. Okay? Questions? Now, observe that x cannot take negative numbers. And I have already explained that. Because again, you have fourth root of 32x and x here. It's just x, so your x must be greater than or equal to 0. So we don't have to put the absolute value here. Okay. Now, I mentioned earlier that this guy here, okay, that this guy here is almost simplified, okay? The denominator has radical. And to simplify this further, we don't want any radicals on the denominator. So the goal is to rationalize the denominator. So when radicals occur in quotients, it is customary to rewrite the quotient so that the new denominator contains no radicals. Okay? So this process is called rationalizing the denominator. Okay? When rationalizing a denominator, the following identities may be helpful. You have this, a minus b. You can write it as a squared plus, square root of a plus square root of b times square root of a minus square root of b. So if you look at this, this is like a formula for the difference of two squares. In fact, it is. Why? Because if you look at this side here, if you look at this side, this is just what? Square root of a squared minus square root of b squared. But square root of a squared, that's just a. And square root of b squared, that's just b. Okay? So a minus b, that's equal to square root of a plus square root of b times square root of a minus square root of b. Okay? Or you can write a plus b as cubes if cubes appear in the denominator. Okay? So in here, you have a plus b, that's equal to cube root of a plus cube root of b times cube root of a squared minus cube root of a cube root of b plus cube root of b squared. Or if you have minus, you just put those, you replace these signs here. So a minus b equals cube root of a minus cube root of b times cube root of a squared plus cube root of a cube root of b plus cube root of b squared. And these two guys here, again, they came from sum and difference of two cubes. Okay? Sum and difference of two cubes. So this right-hand side, okay, this right-hand side here and in here, what will happen is that you will have cube root of a cube plus, sorry, that should be cube there, and then cube root of b cube. That's for this guy here. And of course, if you have this guy, you just have the minus. So you will have here a plus b and a minus b. So these two guys here will be helpful if your denominator contains cube roots. This guy here will be helpful if your denominator contains square root. Okay? Now, we call these two guys here conjugates of each other. So, square root of a plus square root of b, the conjugate is square root of a minus square root of b. And if you have square root of a minus square root of b, the conjugate is square root of a plus square root of b. So conjugate. I'll be using the term a lot of times when we have this guy here. I mean, rationalizing denominator. The same is true with this. This guy here, the conjugate is this. And of course, this guy here, the conjugate is this. Okay? So example, let us rationalize the denominators here. Okay? So here you have 2 over square root of 5. 2 over square root of 5. When your denominator contains only a single term, like this guy here, square root of 5, all you need to do is to multiply and divide by that radical on the denominator. So 2 over square root of 5, you multiply it by square root of 5 divided by square root of 5. And of course, you will have here on the denominator, square root of 5 times square root of 5, that's square root of 5 squared. Okay, so the numerator, you just have 2 square root of 5. The denominator, you have square root of 5 squared. And if you do this guy, you will have 5 on the denominator. So 2 square root of 5 over 5, and this is now the rationalized version of 2 over square root of 5. Okay? Another example here, you have 6 over 5 cube root of 3. Now, you have here cube root of 3. Okay? What you need is to multiply cube root of 3 by cube root of 3 squared. Because if you do this, you will have cube root of 3 times 3 squared, and this will give you cube root of 3 cube. Okay? So, you multiply and divide both, you multiply and divide this expression by cube root of 3 squared. So, we have here 6 over 5 cube root of 3 times cube root of 3 squared divided by cube root of 3 squared. So if we simplify this, you will have 6 cube root of 3 squared. That's for your numerator. For the denominator, you will have 5 cube root of 3 cube. And now, this guy here, it's just 3. Okay? And you have 5 times 3, that's 15. But 6 over 15, you can simplify it. You will end up with 2 over 5. And of course, you still have here the cube root of 9. So 2 cube root of 9 divided by 5. So this is the rationalized version of this guy here. Okay? Now, suppose we have this. So 2 minus square root of 5 over 2 plus 3 square root of 5. So the denominator, we have square root of 5. Okay? So there's radical. But furthermore, your denominator is a sum. So when you have something like this, when you have sum in the denominators and involves radicals, you multiply and divide the expression by the conjugate of the denominator. So you have plus in here, okay, you have plus in here, you multiply the corresponding minus. So you have 2 minus the square root of 5 over 3 plus over 2 plus 3 square root of 5 times 2 minus square root of 5 over 2 minus square root of 5. So look at that. This is your denominator. It's a plus. You need to multiply the minus. And that's what you're going to do in both the numerator and denominator. Okay? And when you do this, what will happen is you have 2 squared minus 3 square root of 5 quantity squared. That's difference of 2 squares. Okay? Okay? So if we do that, well, 2 squared. So I'm only talking about the denominator here, okay? The denominator. So 2 squared, that's equal to 4. Then minus, in here you have 3 squared, square root of 5 squared. Okay? But 3 squared, that's 9. And of course, square root of 5 squared, that's 5. Okay? So that's for your denominator. For the numerator, you multiply, of course. But you do this by distribution or by your FOIL method. So similar to those methods. Okay? So for the numerator, let me write it here. You have 2 minus square root of 5 multiplied to 2 minus 3 square root of 5. So if we use FOIL method, this is your first. This is your outer. This is the inner. So this guy here, it's the inner. And then we have here last. This guy here, it's the last. Okay? Which means if we do this, we will have 2 times 2, that's 4. Then outer, that's 2 times negative 3 square root of 5. That will give you 6 or negative 6 square root of 5. And then the inner, you have minus square root of 5 times 2. So you will have minus 2 square root of 5. And then negative square root of 5 times negative 3 square root of 5, you will have plus 3 square root of 5 quantity squared. And therefore, you will have what? 4 minus, you have here, minus 6 square root of 5 minus 2 square root of 5. That's minus 8 square root of 5. And then here you have 3 times square root of 5 squared. Square root of 5 squared, that's just 5. So you will have here 3 times 5, or that's equal to 15. So 3 times 5, or this guy here, it's just 4 minus 8 square root of 5 plus 15. Okay?
Sorry, sir.
Yeah.
Over there, when you're doing the foil, when you're doing the O in foil, the when you bring the 2, you do 2 times the square root of 5.
2 times negative 3 square root of 5.
Okay, thank you, sir. All right,
Yeah.
perfect.
So this whole expression here, negative 3 square root of 5.
Thank you.
You're welcome. So we have this. All we need to do is to combine this 4 and 15. On the denominator here, let's just write this as 4 times 9 times 5. And then we'll just simplify this. But as you can see, the denominator, it no longer has radical. The numerator doesn't matter if it still has radicals or not. Okay? As long as the denominator is free of radicals, then we're good. So if we do this, we will have this guy here. You have 4 minus 8 square root of 5 plus 3 times 5. 3 times 5 here, it's 15. In here, you have 4 minus 9 times 5, and 9 times 5 here, that's 45. So we simplify this. 4 plus 15, that's 19. And of course, we still have 8 square root of 5. So we have minus there. So you have this. And for the denominator, you have 4 minus 45. That's equal to minus 41. So you can write the expression this way. Okay? You can write the expression this way. You put the negative outside of the fraction. And you can even distribute this negative in the numerator. So this is the same as 8 square root of 5 minus 19 over 41. If you don't want to see the negative outside the radical in here, or outside the fraction in here. So you can distribute it in the numerator and you will have this final expression. So any of the three guys here is acceptable. Okay? Questions? Let's do another example in here. So let's have more algebra in a sense that we just see letters in here. We have square root of x plus h minus the square root of x over square root of x plus h plus square root of x. So in the denominator, we have square root of x plus h plus square root of x. The conjugate is, we just replace this plus with a minus. So we multiply and divide this by square root of x plus h minus the square root of x. Okay? So again, because this is plus in here or in here, we need the minus sign. But it just so happened in the numerator, we have the same expression. So square root of x plus h minus square root of x. So you can use your binomial expansion, perfect square, okay? While for the denominator, you use your difference of two squares. So for the numerator, okay, you will have something like this. Square root of x plus h minus the square root of x quantity squared. And for the denominator, well, you will have x plus h minus x. Okay? And then let us expand the numerator. The numerator will become x plus h. You have that square root, but you square it, minus twice the product of square root of h, square root of x, plus square root of x squared. So that's the numerator. And of course, for the denominator, you'll just simplify this. So x plus h minus x, denominator is simply h. And for the numerator, just simplify it. You will have x plus h minus 2 square root of x times x plus h. So you can combine these two guys. You can put them together. Okay. And then in here you have plus x. Of course, denominator, it's just simply h. And you can combine x plus x, that's your 2x. Then you have the plus h minus 2 square root of this guy here. So, we have this guy, okay? And then simplifying, we'll get this final expression. Okay? So let us look at some more properties of radicals. And in the following, what we will do is to connect exponents and radicals. Okay? So in here, we have the following. So if a is a real number and n is an integer greater than or equal to 2, then square root of a, that's the same as a raised to power 1 over n. Of course, provided that this it's nth root of a, okay? Provided that the nth root of a exists. So again, if a is a real number and n is greater than or equal to 2, which is an integer, then the nth root of a, that's equal to a raised to 1 over n, provided that nth root of a exists. Okay? So if a is a real number and m are integers containing no common factors, okay? So containing no common factors with n greater than or equal to 2, then we have the following expression. A raised to m over n, that's the same as the nth root of a to the m, or that's also the same as the nth root of a raised to power m. Okay? Provided that nth root of a exists. So in here, what we are saying is that radicals, they are just simply exponents. But the exponents or the power, they are fractions. Okay? So if you recall, a to the r times a to the s, that's equal to a raised to r plus s. And you have a raised to negative r, that's equal to 1 over a to the r. So if you have fractional exponents, then these properties still hold. Okay? So our goal, simplify the expressions involving exponents or radicals. And if you have radicals there, it's easier to work on exponents. So you convert the radicals into exponents. Okay? So for example, you have this expression and you want to simplify this. And furthermore, the final expression must only contain the positive exponents. Okay? So you have for x raised to negative 1, y raised to 1/3 quantity raised to 3 halves, all over xy raised to 3 halves. So from here, we have the properties, laws of exponents. So what we do is we can distribute the exponents over the product. Okay, so we will have 4 raised to 3 halves. Then in here, x raised to negative 1. Then you have the power 3 halves. So you multiply negative 1 times 3 halves. So you have negative 3 halves. Then y raised to 1/3. And then you raise it to 3 halves. So you multiply 1/3 and 3 halves. So 1/3 times 3 halves. And on the denominator, you just distribute these 3 halves. So you will have this expression. And then we'll just simplify everything here. If you look at this, 4 raised to 3 halves. So 4 raised to 3 halves, this is equal to 4 raised to 1 half raised to 3. But 4 raised to 1 half, that's just 2. And you raise it to 3, that's equal to 8. That's why you see the 8 in here. Okay? On the other hand, you have here negative exponent for x. On the denominator, you have positive exponent for x. So the negative exponent for x in the numerator, you bring the expression to the denominator, and you will have to put the negative. So x raised to negative 3 halves from the numerator, we bring it to the denominator, you have x raised to negative of negative 3 halves. And then here, 1/3 times 3 halves, the 3 will cancel. So this expression here, you will just have y raised to 1 half. And then in the numerator, you have this y raised to 1 half. On the denominator, you have y raised to 3 halves. So exponent 3 halves here in the denominator is greater than the exponent 1 half in the numerator. So you bring y raised to 1 half to the other side. That's why you have now here y raised to 1 half on the denominator. Okay? And then you just simplify. We just simplify. So you have here x raised to 3 halves times x raised to negative of negative 3 halves. It means that you'll just have to add them, 3 halves plus 3 halves for the power of x. In here, you have y raised to 1 half, y raised to negative 1 half. So you will have 3 halves minus 1 half. Okay? And you will get this expression now. Then you just simplify 3 halves plus 3 halves, that's 6 halves. You'll just get 3 as exponent of x. And then 3 halves minus 1 half, you'll just get 2 halves or 1 as exponent of y. And therefore, the final expression will be 8 over x cubed y. Okay? Questions? Now, suppose we have this. So, x plus 4 raised to 1 half minus 2x. X plus 4 raised to negative 1 half. And then the denominator, you have x plus 4. Okay? So this guy, it looks like it's already rationalized. But notice you have here negative exponents. And we don't want negative exponents. So we'll try to work on this. Okay? So for this, we're going to rewrite it as follows. So particularly this guy here, you have your x plus 4 raised to negative 1 half. you can rewrite it as 1 over x plus 4 raised to 1 half. That's why we have this expression in here. So the numerator becomes this guy here. The denominator, it's as is. Now we combine these two expressions in here. Okay, we combine these two expressions here, and we will have the following. So what happened there? You will have, let me go back, you will have x plus 4 raised to 1 half times x plus 4 raised to 1 half minus 2x all over x plus 4 raised to 1 half. That's for your big numerator. And then all over, you have x plus 4 on the big denominator. Correct? So remember, addition or subtraction of fractions or rational expressions. So this guy here, x plus 4 raised to 1 half times x plus 4 raised to 1 half, that's equal to x plus 4 raised to 1 half squared. Or it's simply x plus 4. And then you will have that minus 2x there. So simplified version will be x plus 4 minus 2x all over x plus 4 raised to 1 half. And then everything all over x plus 4. And then this guy here, it's actually division, so we can apply the definition of division. We convert the big denominator into multiplication. So we convert this expression into multiplication, and the denominator will need the reciprocal. So we will end up with this expression. So x plus 4 minus 2x, that's minus x. And then, of course, x plus 4 minus 2x, that's 4 minus x. You still have the 4 there. And then this guy here, you will have x plus 4 raised to 1 half, and then you have your x plus 4. So if you don't see that immediately, this is simply x plus 4 minus 2x divided by x plus 4 raised to 1 half. You multiply this by 1 over x plus 4. So that this big denominator, we get the reciprocal of that. And then we have the multiplication. So you have this expression after multiplying the denominators, and we simplify it as follows. So 4 minus x all over x plus 4 raised to 3 halves. So x plus 4 raised to 1 times x plus 4 raised to 1 half, that is equal to x plus 4 raised to 3 halves. Okay? Question?
Why is it x plus 4 onto like 3 half?
This guy here?
Yeah.
Yeah, because you have this. X plus 4 in here, it's raised to power 1. So 1 plus 1 half, that's 3 halves.
Okay.
So we applied laws of exponents. Okay?
Yeah, thank you.
You're
Sorry, sir.
welcome. Yeah.
For the explanation you just made, you said there's a one on top of that x plus 4
Mm-hmm.
over there. So it's one. What do we do? Like there's the 1 half there. So it's 1 plus 1 or
1 plus 1 half.
okay, okay, perfect.
Yeah.
Thank you, sir.
You're welcome. Other questions? Now, let's have this expression. So 1 plus x squared over 2 squared of x minus 2x squared of x all over 1 plus x squared squared. So in here, we don't have negative exponent, but we have here a fraction and the denominator is or has radical. So we simplify this. In fact, this is a complex radical. So we simplify it. Okay? So from here, we combine. Okay, we combine them. We will end up with this. And how did that happen? So you have 1. So just looking at the big numerator here. So you have 1 plus x squared over 2 square root of x minus 2x square root of x. This is equal to 1 plus x squared minus 2x square root of x times 2 square root of x divided by 2 square root of x. And then you have here you have here 2 times 2, that's your 4 there. And then you have square root of x times square root of x, that's just x. But there's an x in here, that's why we have x squared here. Okay? So that's our big numerator. When we simplify it, we get this guy here. And then further simplification, we will have this. So 1 plus x squared minus 4x squared, that's 1 minus 3 square root of x. And then you have 2 square root of x in here. And then the big denominator, it's 1 plus x squared squared. Okay? And division again, we convert this to multiplication. Okay? We convert this to multiplication. So it will be 1 minus 3x squared over 2 square root of x times 1 over 1 plus x squared squared. So if we multiply this, okay, we will get this expression here. So 1 minus 3x squared over 2 square root of x, 1 plus x squared squared. Okay? And finally, denominator, this has square root of x. Okay? This has square root of x. So we can just multiply and divide by that square root of x. So this guy here, when multiplied to the square root of x on the denominator here, okay, we will have 1 minus 3x squared times square root of x all over 2x times 1 plus x squared squared. So this is the final expression. Okay. Questions?